Nitrox. In this module, you will learn about the gas mixes, particularly nitrox, used in recreational diving. You will learn to calculate percentages and partial pressure, how to use an oxygen analyzer, and will calculate the maximum depths that can be reached with different nitrox mixes. Nitrox. On the open water diver course, you learn that air is a mixture of gases. The proportion of the elements varies from place to place and over time. However, on average, air can be considered to be made up of 79% of inert gas and 21% of oxygen. You also learned that the absorption of inert gas in the different compartments is the limiting factor for dives using air. The absorption and release of inert gas are linked to the ambient pressure. At a certain depth, this corresponds to an absolute pressure equal to the atmospheric pressure plus 1 atmosphere every 10 meters, 33 feet of descent. The absorption of an inert gas is directly proportional to the partial pressure of the gas. This is equal to a percentage of the absolute pressure, the same in value as the percentage of the gas in the breathing mix. For example, the partial pressure of the inert gas in the air is 79% of the absolute pressure. So, if we want to absorb less inert gas, we have just 3 ways of doing it: reduce the dive time, reduce the absolute pressure, or rather the depth, or reduce the partial pressure of inert gas. In this last case, a nitrox mix is used. By using nitrox instead of air, the reduction of the partial pressure of nitrogen enables us to stay longer underwater while still making a no-stop dive. For the same reason, you can make longer repetitive dives or shorter surface intervals. What is more, there is less time to wait before increasing altitude or flying. Finally, there is a reduction in the volume and number of microbubbles present in the blood at the end of a dive. Nitrox and ene. The term nitrox identifies a mixture composed of oxygen and nitrogen, so air can also be considered a nitrox mix with 21% oxygen. If with the enrichment of this gas we obtain a nitrox mix whose percentage of oxygen is greater than that of air, the percentage of nitrogen is consequently reduced. Otherwise, we can take nitrogen out of the air. The correct name of the mixes we use for diving activities today should therefore be oxygen-enriched air or nitrogen-impoverished air, depending on how the mixes are produced. Other terms are used to define gas mixes, such as ene, which stands for enriched air nitrox, followed by a number representing the percentage of oxygen in the mix. For example, ene 32 means a mix in which the percentage of oxygen is equal to 32%. Limits imposed by oxygen. However, there are also disadvantages to using nitrox. When a nitrox mix with 32% oxygen reaches the pressure of 2 atmosphere, the oxygen has a partial pressure equal to 32% of 2 atmosphere, that is, 0.64 atmosphere. But the human body evolved in an environment that has a percentage of oxygen that varies very little, and so is only able to tolerate different partial pressure of oxygen than usual for short periods of time. If the partial pressure of oxygen is too high, a condition defined hyperoxia, problems of oxygen toxicity arise. The most important is the poisoning of the central nervous system. The effect of hyperoxia on the human body causes various signs and symptoms: muscular tremors, wrinkling of the facial muscles, cramps, nausea, dizziness, anomalies of sight and hearing, difficulty breathing, anxiety, lack of coordination, tiredness. In the end, hyperoxia leads to a convulsive crisis similar to an epileptic fit. The crisis begins with contractions and stiffening of the body, followed by a phase of violent convulsions. During the crisis, the victim loses consciousness and then comes round again a short time after. A convulsive crisis underwater can lead to the victim drowning. It is therefore obvious that a situation such as this means that divers must prevent a crisis arising. Today, most of the diver training agencies agree that the maximum accepted limit for the partial pressure of oxygen is 1.4 ATA, which can reach 1.6 ATA in an emergency. You can stay at any pressure for a limited duration, measured in minutes, which decreases when the partial pressure of oxygen increases. You can also calculate the percentage of exposure to oxygen, that is, the part of maximum possible duration. How to work this out is a subject dealt with on the PSS Nitrox Diving specialization courses. For now, it is enough to know that you must not exceed the partial pressure of 1.4 ATA and that the Nitrox Dive computers will show the percentage of oxygen exposure on the display. Calculating the partial pressure and maximum operating depth. There is an easy way of quickly remembering all the operations concerning partial pressure. Draw a large T. Write the letters PG above it, PA to the left, and FG to the right. PG is the partial pressure of the gas, PA is the absolute pressure, and FG is the fraction of the gas, or rather the percentage divided by 100. If we have to calculate the partial pressure of the gas, just cover the letter PG with your finger. The letters PA and FG stay on the same level, so we can say that the partial pressure of the gas is equal to the absolute pressure multiplied by the fraction of the gas. If we are looking for the absolute pressure, just cover the letters PA with your finger. The letters PG are now above FG, so we can say that the absolute pressure is equal to the partial pressure of the gas divided by the fraction of the gas. Let's look at a practical example. We are on a dive at 30 meters, 100 feet, breathing a nitrox mix with 40% oxygen. Let's work out the partial pressure of this gas. The fraction of oxygen is 0.4, and the partial pressure of oxygen is the same as the absolute pressure, equal to 4 ATA, multiplied by the fraction of the gas. The result is 1.6 ATA, which is too high. In fact, the maximum depth that can be reached is that for which the partial pressure of oxygen in the breathing mix is 1.4 ATA. Let's work this out for our gas mix. We have to find the absolute pressure, which is equal to the partial pressure of the gas, 1.4, divided by the fraction of the gas, 0.4. The result is 3.5 ATA. The depth at which you reach this absolute pressure is 25 meters, 82 feet. This is, therefore, the maximum operating depth for nitrox at 40% oxygen. Nitrox and equipment. In some cases, the use of nitrox requires dedicated equipment, which cannot be used for other mixes. The problem derives from the action oxygen has on the various components of the equipment. In fact, oxygen is a supporter of combustion and can cause fires and explosions. You therefore have to take special precautions. For example, don't put the gas in contact with surfaces that have not been cleaned for oxygen. Silicone grease should not be used, only special lubricants. It is also necessary to replace the seals and O-rings with those made with materials that resist oxygen. Unless indicated by laws or local regulations, this necessity only arises if the percentage of oxygen exceeds 40%, the maximum percentage used in recreational diving. However, these precautions may also be used even for mixes with a lower percentage of oxygen, depending on how the mix is prepared. There are various methods for preparing nitrox. Today, a common method is a static mixer, known as a stick or constant flow mixer, in which the oxygen is added to the air before the compressor intake. There are no particular problems with this method because the percentage of oxygen, always less than 40%, is mixed well before entering the compressor. The same is true for the membrane type, which uses molecular sieves to extract part of the nitrogen from the air. Other centers use a partial pressure method for filling cylinders. This means that pure oxygen is put into the cylinder first, and then filling is completed with air. In this case, pressurized pure oxygen enters the cylinder valve, so cylinders and cylinder valves must be oxygen clean. If one of these cylinders is later filled with air that is not sufficiently clean, it gets dirty and has to be disassembled so the inside of the cylinder and the valve can be cleaned again. This is why all the cylinders cleaned for nitrox are always specially marked with a special written or colored label. On the dive, you have to use a computer that can be set for nitrox as a breathing gas, generally between 21% and 50% of oxygen. The Nitrox Dive computer can also be set to the maximum partial pressure of oxygen with an alarm, and it also indicates the percentage of exposure to oxygen to prevent hyperoxia. Analyzing the nitrox mixes and planning. It is always necessary to analyze the mix personally before using it. If the diving center doesn't allow you to make the analysis personally, ask them to check it again in your presence and make sure that the percentage of oxygen is correct. The maximum acceptable variation between the indication of the analyzer and the percentage of oxygen requested is more or less 1%. The most common analyzer has an electrochemical sensor. It is best to analyze the mix from the first stage of the regulator using the BC house and inserting a special flow limiter. Do not use the analyzer in direct contact with the cylinder valve. The analyzer is very delicate and sensitive. The heat of your fingers, the inclination of the probe, and humidity can influence the reading, so always take great care when using it. Before analyzing the mix, you need to calibrate the instrument with air. In practice, a cylinder filled with air is analyzed, and when the reading of the instrument has stabilized, you set the reading to 21%. Only after doing this can you then go on to analyzing the mix. Your instructor will have you analyze the mixes and then plan and make the Nitrox Dive of the Advanced Open Water Diver course, getting you to compare the data of a Nitrox computer to an extra one carried by the instructor that has been set for air. You will be surprised at the time advantage that Nitrox offers. Happy diving!